Our task is to find the vector product or the cross product of two vectors A and B, being with the components 1, 0, 0, and 0, 0, 1. Recalling a definition, the cross product of two vectors is a vector as well, and it is orthogonal to two vectors being multiplied. And in order to calculate its components or its coordinates, we have to solve a 3 by 3 determinant. Let's see. Suppose we have two vectors, A and B, being with the components A1, A2, A3, and B1, B2, B3. We might also recall that these components of the vectors are called the I components, these are called the J components, and these are called the K components. So the determinant we're going to have to solve looks as follows. We have the cross product of two vectors A and B equals to a 3 by 3 determinant, and the first row of the determinant is the standard basis I, J, K. The second row is formed by the first vector in the product, which is A. So we have A1, A2, A3. And the third row is the vector B. So we have B1, B2, and B3. Now, in case you have forgotten how to solve determinants, or you're willing to learn how to do so, you might want to check one of our previous videos, and namely the ones concerning finding determinants. So now I'm going to substitute the initial vectors given into the formula, into the determinant, and proceed. So we have A cross B equals to a 3 by 3 determinant, where the first row still is the standard basis I, J, K. Then I have vector A, 1, 0, 0, and then I have vector B, 0, 0, 1. I'm calculating this determinant by opening it by its first row. So I have 1, so I have I times 0, minus J times 1, plus K times 0, which means that the product vector of these two vectors, the cross product of these two vectors, is the vector with the coordinates 0, 1, and 0.